Now we're gonna start our work, energy, and power revision. Question number 1. A body of mass 4.2 kg with initial speed 5.6 meter per second begins to move up an incline as shown. This body will be momentarily brought to rest after colliding with a spring constant 220 Newton per meter. The body stops a vertical distance of 0.85 meter above its initial position. Determine the amount by which the spring has been compressed. There are no frictional force. There are no frictional force. There are no external force doing work. So work done equals to 0. The system is isolated and we have conservation of total energy. Change in kinetic energy plus a change in potential energy equals to 0. Initially, we have only kinetic energy, which is 1/2 mass times velocity squared equals to 1/2 times mass is 4.2, initial velocity is 5.6, so 5.6 squared, so that gives us 65.856 joule. Final energy when the body completely stops, we have gravitational potential energy and elastic potential energy as the spring will be compressed. Mass is 4.2, gravitational field strength is 9.81, height is 0.85 plus spring constant is 220 times x squared. The question asking the amount by which spring has been compressed, so we are looking at x squared. Solving this gives us 34.99 plus 110x squared, and equating initial to final energy, we have solving this 110x squared equals to 30.866 and x squared equals to 0.2806. It gives us x equals to 0.53 meter. Part B, we repeat the previous example equation, but now there is a constant frictional force opposing the motion along the uphill part of the path. The length of this path is 1.2 meter and the frictional force is 15 Newton. Normally, when frictional force acting on it and object is finally come to rest, we normally use work energy theorem. That is, work done equals to change in kinetic energy. Work done equals to change in kinetic energy. Work done is force times the distance times cosine theta equals to final kinetic energy minus initial kinetic energy. As a constant frictional force opposing the motion, the displacement forward is opposite direction to the frictional force. So frictional force and the displacement is anti-parallel. So cosine theta is going to be cosine 180 degree. So force is 15 times the displacement is 1.2, the path, and they are anti-parallel. The frictional force backward and displacement forward, so that anti-parallel cosine 180 degree equals to final kinetic energy minus initial kinetic energy. We have done this in our previous slide. That is 34.99 plus 110x minus initial is 65.856 joule. And solving this, 110x squared equals to 12.866. x squared equals to 12.866 divided by 110, and x equals to 0.34 meter. So work done by the friction is energy that dissipated as thermal energy inside the body and its surrounding. It's generally very difficult to estimate how much of this thermal energy stays within the body and how much goes into a surrounding. So the amount by which spring has been compressed after constant frictional force opposing the motion is 0.34 meter or 34 centimeter. Okay, this is question 2. A ball rolls off a 1 meter high table with a speed of 4 meter per second as shown. Calculate the speed as the ball strikes the floor. The total energy of the mass is conserved as it leaves the table with the speed u. It has total energy given by initial kinetic energy plus gravitational potential energy. As it lands with a speed v, so total energy is just a kinetic energy. The equating these two energies gives mass cancel out. That gives us gh plus 1 over 2 u squared plus 1 over 2 v squared. Both side times 2 times gh plus u squared equals to v squared. Substituting values, 2 times 9.81 times height is 1 plus initial velocity is 4 squared. V squared equals to 19.62 plus 16, that is 35.62, and final velocity before striking the floor is 6 meter per second. Question number 3. Two identical balls are launched from a table with the same speed u. One ball is thrown vertically up and other vertically down. The height of the table from the floor is h. Predict which of the two balls will hit the floor with a greater speed. Very interesting question. Intuition tells us that the left one hit the floor with a higher speed. But let's take a look at. At launch, both balls have the same kinetic energy and the same gravitational potential energy. When they hit the floor, their energy will be only kinetic energy. Energy is conserved. Total initial energy equals to total final energy. Equating these two, m cancel out. Both side times 2gh plus u squared plus v squared. Both side apply squared. That indicates the speed will be identical and equal to v. So, interestingly, the final speed of both balls equal, which is equals to a root square of 2gh plus u squared. It depends on actually the height from the table, which is same, h, and initial velocity u, which are same. A body of mass 2 kg initially at rest. It means it has gravitational potential energy and zero kinetic energy. Slides down a curved path of total length 22 meter as shown in figure. The body starts from a vertical height of 5 meter from the bottom. When it reaches the bottom, its speed is measured and found to have 6 meter per second. Shows that there is force resisting the motion. The only external force that could do work is a frictional force. So we need to find initial total energy and final total energy and find the difference. If they are same, no work done by the friction. If there's a difference, then there are work done by the friction. So only external force that could do work is frictional force, as we mentioned before. Initially, it has only gravitational potential energy. Finally, it has only final kinetic energy. At the top, its initial gravitational potential energy. Mass is 2, acceleration due to gravity is 9.8, and height is 5, that gives us 98 joule. At the bottom, only kinetic energy. 1 over 2 mv squared equals 2. 1 over 2 times the mass is 2, and speed is 6 squared equals 2, 36 joule. So the total energy has reduced, which shows that presence of frictional force resisting the motion. Part B. Assuming the force to have a constant magnitude determines the magnitude of the force. We already know the work done by the friction actually. Work done by the friction is difference of a final kinetic energy minus initial kinetic energy. So we're going to use work energy theorem. Work energy theorem, which is work done equals to change in kinetic energy. Here is work done by the friction equals to final kinetic energy minus initial kinetic energy. Final kinetic energy is 36 minus initial kinetic energy is 98, and the difference is minus 62. This is work done by the friction force. So we found work done by the friction minus 62. And work done equals to minus 62, which is equals to force times the distance times cosine theta, which is minus 62. Force times the distance traveled. The body of mass 2 kilograms slides down a curved path of total length 62. So F times 62 times cosine 180 degree. Why cosine 180 degree? Distance traveled and friction force is anti-parallel. So that's cosine 180 degree. And cosine 180 degree is minus 1. So minus both sides cancel out. That gives us 2.8 Newton. A 0.5 kilogram battery operated toy train moves with a constant velocity 0.3 meter per second along a level track. The power of the motor in the train is 2 watt and the total force opposing the motion of the train is 5 Newton. Determines the efficiency of the train's motor. So it's moving with the constant velocity. The net force equals to 0. Drag force equals to engine force, which is equals to 5 Newton. The total force opposing the motion, which is the drag force, it's 5 Newton. As the train moving with constant velocity, the net force equals to 0, which means drag force minus engine force equals to 0, which means drag force equals to engine force, which is 5 Newton. Input power is given. The power of the motor in the train, which is input power, that is 2 watt. We need to find output power, which is the power used in moving the train. That is the engine force 5 times velocity 0.3, that is 1.5. Efficiency equals to output power divided by input power. Output power is 1.5, which is power used in moving the train, a useful power. and total input power is 2. That gives us 0.75, which is 75%. The efficiency of the train motor is 75%. B, assuming the efficiency and the opposing force stays the same. Calculate the speed of the train as it climbs an incline of 10 degrees to the horizontal. Engine force forward, and we have frictional force opposing the motion, and the weight has X component, which is W sine theta. So the component of the train's weight acting down the plane is W sine theta. And the force opposing the motion, which is frictional force, 5 Newton. As the train moves with constant velocity, net force in X component along the slope equals to 0, which means F minus the component of the train's weight acting down minus frictional force equals to 0. So F force, engine force, equals to mg sine theta plus the friction force. Mass is 0.5, acceleration due to gravity 9.81, sine 10 degree plus frictional force 5. That gives us 5.85 Newton. But from the part A, the efficiency is 0.75. We have P out over P in, and we get a power output, should be same power output actually. Efficiency times input power, efficiency 0.75, stays the same, times input power is 2 watt. That gives us 1.5, same as before. And output power equals to engine force times velocity, and velocity equals to output power divided by force applied, engine force. Output power 1.5, force is 5.85. That gives us 0.26 meter per second.